Our next module is boats and streams. So these are a special kind of problems. The problems are related to the motion of bodies in streams. What do you mean by stream? Stream is nothing but flowing water. Stream is nothing but flowing water. So the motion of bodies in this flowing water and the problems related with it comes under this category of boats and streams. It is a very simple topic as well as very interesting topic, and the formulas are very simple, very limited. The only thing is that we should be knowing about the concepts, very logical concepts of the relative speed. What is the speed of a moving body while it is traveling along the stream or against the stream? So there are a few technical terms, limited formulas, and a very limited type of problems in boats and streams. You may apply other concepts like ratios and proportions, percentage, etc. in boats and stream problem. We have also discussed how to approach such kind of problems in our previous modules. So we will see the technical terms, formulae, and a limited number of problems in boats and streams. As I said, stream is nothing but flowing water. Now, direction, a body moving along the stream, or say the direction along the stream. The stream is flowing like this. So the direction along the stream is called downstream, and the direction against the stream is called upstream. Fine. The direction along the stream is called downstream, and the direction against the flowing water, that is the stream, is called upstream. Now, the speed of a boat in still water. Let us consider that the water is still. It is not moving. Now, in this water body, we have a boat. If the speed of the boat in still water is u kilometer per hour, let us consider that speed of the boat in still water is u kilometer per hour. Let us say, now consider the speed of the flowing water. That is, the rate of the stream is v kilometer per hour. Now, given the data of both these things, we can find what is the downstream speed and what is the upstream speed. That is, what do you mean by downstream speed? The speed of the boat along the direction of the flowing water. The speed of the boat along the direction of the stream is called downstream speed of the boat. Similarly, upstream speed, that is, the direction of the boat against the direction of the flowing water. Direction of the boat against the direction of the stream is called as the upstream speed. Fine. So speed of the boat in still water is u kilometer per hour. Rate of the stream, that is the speed of the flowing water, is v kilometer per hour. Then downstream speed of the boat is u plus v kilometer per hour. And upstream speed is u minus v kilometer per hour. So upstream speed of the boat is u minus v kilometer per hour. A quick revision: direction along the stream is called downstream, against the stream is called upstream. Let us consider the speed of the boat in a still water is given as u kilometer per hour, and the rate of the stream, that is the speed of the flowing water, is v kilometer per hour. Then you will have the downstream speed of the boat given by the formula u plus v kilometer per hour, and upstream speed of the boat is u minus v kilometer per hour. So we have another formula. Only very limited number of formulas in this topic. So the problems are diverse. Now say, consider that the downstream speed is given. Downstream speed of a moving object is given as a kilometer per hour. Upstream speed is v kilometer per hour. Now, what is the speed of still water? Speed in still water. Speed in still water will be half into a plus b kilometer per hour. rate of the stream is equal to half into A minus B kilometer per hour. The downstream speed of the object is given as A kilometer per hour. Upstream speed of the boat is given as B kilometer per hour. In that case, the speed of the boat in Stillwater is given by the formula half into A plus B kilometer per hour. The rate of the stream, that is the speed of the flowing water, will be half into A minus B kilometer per hour. With this knowledge of two formulas and the technical terms, we can approach any problem, approach and solve any problems based upon boats and streams. We'll see some example problems. So here is a problem. In 1 hour, a boat goes 11 km along the stream and 5 km against the stream. The speed of the boat in the Stillwater is. It is a very clear problem where you can straight away apply your formula. As I have said, in any problem you have to find the technical term. Understand the statement very clearly, understand the problem statement, extract the data, then go for formulas. So in 1 hour, a boat goes 11 km along the stream. Along the stream in the sense it is downstream, and against the stream is upstream. So what is the downstream speed? Let us keep the downstream speed as ds. And what is the downstream speed? 11 km per hour. Why it is per hour? In 1 hour. The question itself is given for 1 hour. So 11 km per hour. Next, what is the upstream speed? That is upstream speed is equal to 5 km per hour. And it is a simple logic that the downstream speed will always be greater than the upstream speed if the time is the same. Now for 1 hour, the downstream speed will be greater, whereas the upstream speed will be lesser, because the downstream speed is nothing but the speed of the moving object along the stream. So 11 km per hour, 5 km. What you have asked? The speed of the boat in Stillwater. Speed of boat in Stillwater. So speed of the boat in Stillwater. Let this be Stillwater speed, SWS. Okay, Stillwater speed, SWS. What is SWS? You have the formula, that is speed in Stillwater is equal to half into A plus B kilometer per hour. We have learned this formula. Speed of the boat in Stillwater is half into A plus B kilometer per hour, where A and B are the upstream and downstream speed respectively. In this case, SWS is equal to half into ds plus US is equal to half into 11 plus 5, that is 8 km per hour. So we have found the speed of the boat in Stillwater, that is 8 km per hour. Very simple problem. So here is a problem. A man can row 18 km per hour in Stillwater if it takes thrice as long as rowing up to row down the river. What is the rate of the stream? Now, what is the question asked? What is the data here? A man can row 18 km per hour in Stillwater. So, rate of the man in Stillwater. What is given is, so the rate of the man in Stillwater is 18 km per hour, and from the given data you can understand that man's upstream rate is x km per hour. Similarly, the man's downstream rate is 3x km per hour. Why is it 3x km per hour? Because the man's downstream rate, he takes thrice as long as rowing up. So it is thrice upstream speed. So the man's downstream rate is 3x km per hour. Now, what is the data given to you? Rate of the man in Stillwater. Now, what is the formula for finding the rate of the man in Stillwater? Rate of the man in Stillwater is nothing but, you can get it by half into downstream speed plus upstream speed, isn't it? So the value of half into downstream speed plus upstream speed is 18 km per hour. Now what is downstream speed value? This is your ds, this is your us, and this is your ds. So substitute these values. So half into 3x plus x, it is nothing but 2x. So what is the value of 2x? 2x is equal to 18 km per hour. 2x is equal to 18 km per hour. So x is equal to 9 km per hour. So the value of x is 9 km per hour. So what is the downstream speed? Downstream speed is equal to 27 km per hour and upstream speed is equal to 9 km per hour, isn't it? Because the value of x is 9. Now what you are asked to find? You are asked to find the rate of the stream. Now we have a formula for finding the rate of the stream. So what is the rate of the stream? Formula for finding the rate of stream. Rate of the stream is nothing but half into ds minus us, that is half into downstream speed minus upstream speed kilometer per hour. So you know what is the downstream speed? It is 27. Upstream speed is 9 km per hour. So the value is 9 km per hour. So the rate of the stream is 9 km per hour. The same value of x. The rate of the stream is 9 km per hour. Extract the data, substitute the formula, find the what is the downstream speed, what is the upstream speed, then substitute in the formula to get the value of rate of stream. A man can row 7.5 km per hour in Stillwater. In a river running at 1.5 km per hour, it takes him 50 minutes to row to a place and back. How far off is the place? So understand the problem well. What is given? A man can row 7.5 km in Stillwater. Speed of the man in Stillwater is given. So first note it down. Speed of man in Stillwater, that is Stillwater speed, is 7.5 km per hour, isn't it? This is Stillwater speed. Okay, Stillwater speed. Now if in a river running at 1.5 km per hour, the speed of the flowing water, that means the rate of the stream, the rate of stream is 1.5 km per hour. Okay, so let this be the Stillwater speed, SWS, Stillwater speed, and the rate of the stream, let rate of the stream be RS. So from these two data you can find the downstream speed. Downstream speed. What is the speed of the man downstream? That is the downstream speed. Downstream speed is SWS, Stillwater speed plus rate of stream. That is 7.5 plus 1.5 is equal to 9 km per hour. So this is the downstream speed of the man in the river. Downstream speed is equal to Stillwater speed plus rate of the stream. Similarly, upstream speed is equal to Stillwater speed minus rate of stream. So 7.5 minus 1.5 is equal to 8 km per hour. It's equal to 6 km per hour. Fine. 7.5 minus 1.5 is 6 km per hour. So now you have the downstream speed and upstream speed. Now what it is given? It takes him 50 minutes to row to a place and back. How far off is the place? That is, now he is at a particular point. So the river is flowing like this. He is at a particular point, say A. Now from A he goes to a place, say B. And from B he comes to the same place. That is, he flows. From A he goes upstream to B. From B he moves downstream to A. To do this process, it takes him 50 minutes. The total time taken to move from A to B, B to A, that is upstream and downstream, is 50 minutes. Now you have to find the distance between A and B. How far B is from A. Distance between A and B. So you know speed is equal to distance by time. Downstream speed is nothing but downstream distance by downstream time. The distance is same here. So downstream speed is equal to distance by downstream time. Similarly, upstream speed is equal to upstream distance by upstream time. So let us see how to find out the answer. You have to find the total distance. It takes him 50 minutes to row to a place and back. So the total time is given. You have to find the distance between A and B. Now the first step is downstream speed. What is speed? Speed is equal to distance by time. So the downstream speed is 9 km per hour. Upstream speed is 6 km per hour. Now take these two values. We have the total time taken for the journey. Now let us say the distance be x kilometer. Let the distance be x kilometer. Now that is A, B. Let this distance be x kilometer. Now downstream speed. Speed is equal to distance by time. So the value of time is given, total time. Now time is speed is equal to distance by time. So time is equal to distance by speed. You know what is the value of distance? Distance is x kilometer. Speed. What is the downstream speed? It is 9 km per hour. Now add this with upstream, x by 6. The total time. So this is the time taken for downstream. Downstream time, to be very clear, the distance is x kilometer. So the total time is 50 minutes. So what is this total time? Downstream time plus upstream time is equal to 50 minutes, isn't it? So what is downstream time? Downstream time is x by 9. X by 6 is the upstream time, is equal to 50 by 60. X is the distance, D is the downstream speed. So distance by downstream speed will give you the downstream time. X is the distance, 6 is the upstream speed. So distance by upstream speed will give you the upstream time, is equal to 50 by 60. What is this? That is 50 minutes is represented in terms of hours. 1 hour is equal to 60 minutes. So 50 minutes is nothing but 50 by 60 hours. Now solve this equation, you will get the value of x. That is, x is nothing but x plus 9 plus x by 6 is equal to 5 by 6. So 6x plus 9x is equal to 9 into 54, 5 by 6, isn't it? So 15x into 6 is equal to 5 into 54, 3x, 1 7, 9. X is equal to 3 kilometers. X is equal to 3 km. On solving this equation, you get x is equal to 3 kilometer. The distance between A and B is 3 kilometers. So using the Stillwater speed and rate of the stream, find what is the downstream speed and the upstream speed. Now the total time is given. You know what is speed formula. Speed is equal to distance by time. So the total time, as we have seen, the total time is 50 minutes. It is equal to downstream time plus upstream time. Downstream time is equal to downstream distance by downstream speed. The distance is same. So we have taken the distance to be x kilometer. X by what is the downstream speed? 9 kilometer per hour. Distance is x. What is the upstream speed? 6 kilometer per hour. So this will give you, when added together, will give you the total time. Solve this equation. X is equal to 3 kilometer. So how far is of the place? The place is 3 kilometer distant. So here problem in boats and streams which involves the concepts of ratio is given. Even in our previous discussions of various modules, we have seen applications of other mathematical concept into another. Here, a man takes twice as long as to row a distance against the stream as to row the same distance in favor of the stream. Ratio of the speed of the boat in still water and the stream is water. See, first we have to extract the data. A distance against the stream is upstream speed. Row the same distance in favor of the stream, that is downstream speed. So a man takes twice as long as. So first, from the given data, let upstream speed is equal to x kilometer per hour. Now a man takes twice as long as to row a distance against the stream as to row the same distance in favor. That is, the downstream speed is twice that of the upstream speed. Therefore, downstream speed is equal to 2x, twice. Now, what is the ratio of the speed of boat in still water and stream? So what you have to find, that is, you have to find the ratio of still water speed, that is rate of speed of the boat in still water. Speed of boat in still water is to rate of the stream. Speed of the boat in still water and the speed of the boat in the stream, that is nothing but the rate of the stream. So speed of the boat in still water is half of downstream speed plus upstream speed. Rate of the stream is half ds minus u, downstream speed minus upstream speed. What is the ratio? Half downstream speed is 2x, upstream speed is x into half. This is ratio 2x minus x. Half gets cancelled. 2x plus x is 3x. 3x is to x. X gets cancelled. So 3 is to 1 is your answer. So the ratio of speed of boat in still water and the stream is 3 is to 1. What is the logical meaning of it? That is, the boat travels in still water 3 times faster than when it travels in the stream. The boat travels 3 times faster in still water than that it travels in the stream. So this is a simple thing, the same formulas, same extraction of data. Only thing is that we are representing the result in the form of ratio. The speed of the motor boat itself is 20 km per hour. Rate of the flow of the river is 4 km per hour. Moving with the stream. With the stream is the downstream speed. Boy went 120 km. What distance will the boat cover driving the same time against the stream? So what is the data given? Speed of the motor boat itself. What does that mean? Speed of the motor in still water. Because the speed of the boat is 20 km per hour. In still water, the speed will be 20 km per hour. That is still water speed. Speed of motor boat in Stillwater is 20 km per hour. This is your Stillwater speed, SWS. Rate of flow of river, that is rate of stream. Rate of stream, RS, is equal to 4 km per hour. Moving with the stream, boy went 120 km. So in a given particular time, the distance covered by the boy downstream, that is the downstream distance is 120 km. Downstream distance is 120 km. Fine. You are asked to find the distance the boat will cover in the same time against the stream. In the same time, what will be the distance that will be covered upstream? So let upstream distance is equal to x kilometer. Time is constant in the same time. Now you have these two values, the speed in Stillwater speed, rate of the stream. Using these two values you can find the downstream speed and the upstream speed. You know the formula for finding downstream speed. Downstream speed is equal to half into Stillwater speed plus rate of stream is equal to half into 20 plus 4, that is 24. So 12 km per hour. So this is your downstream speed. What is your upstream speed? Half into Stillwater speed minus rate of stream. Half into 20 minus 4. 8 km per hour. Okay. So you are using these two values, you have found the downstream speed and the upstream speed. Now speed is equal to distance by time. So what do you mean by downstream speed? Downstream speed is equal to downstream distance by downstream time. Now what is downstream speed? 12 km per hour. What is the distance covered? 120 km. You don't know the downstream time. Time is constant. So downstream time is equal to 120 by 12. That is time is equal to 10 hours. Why have I taken simply T? Downstream time and upstream time are one and the same. Time is constant. So time is equal to 10 hours. Now you have time, you have upstream speed. You can find the upstream distance. Upstream speed is equal to upstream distance by time. Time is equal to upstream distance is equal to upstream speed into time. What is upstream speed? Upstream speed is 8. What is time? 10 hours. So what is the upstream distance? 80 kilometers. So upstream distance is 80 kilometers. So from the given problem, write down what is the Stillwater speed, rate of the stream, what is the downstream distance. You are asked to find the upstream distance. So let it be, the unknown variable be x kilometer. Using these two values, you can find what is the downstream speed, what is the upstream speed. The downstream speed formula is here and the upstream speed formula is here. Now you know the general formula we have seen in the previous module, time and distance. Speed is equal to distance by time. Downstream speed is equal to downstream distance by time. Downstream time and upstream time are one and the same because they are constant. So let it be T. So T is equal to 10 hours. For the 10 hours, you can calculate the upstream distance. So here also there is once again two kinds of concept. One is the boats and stream concept, another one is your time and distance formula. Now A boat covers 24 km upstream and 36 km downstream in 6 hours. What is this 6 hours? Okay, fine. While it covers 36 km up and 24 km down in 6.5 hours, find the velocity of the current. You are asked to find the velocity of the current. Velocity of the current is nothing but the rate of the stream. It is given in other words. Velocity of the current. What do you mean by current? A current is nothing but a flowing water, a stream. So you are asked to find the rate of the stream. You know the formula for rate of the stream. Rate of the stream is equal to half into downstream speed minus upstream speed. So first let us write the known values. A boat covers 24 km upstream and 36 km downstream in 6 hours. The total time to cover 24 km up the stream and 36 km down the stream is 6 hours. So now, but we do not know what is the value of downstream speed and upstream speed. So let downstream speed is equal to ds. Let upstream speed is equal to us. What do you mean by the, now as I have said, downstream speed is equal to downstream distance by downstream time, isn't it? Downstream time. Upstream speed is equal to upstream distance by upstream time. You are given the total time, that is 6 hours. You are given two sets of data. Here is one set of data and here is another set of data. That is, see, the total time is 6 hours. Okay, the total time is nothing but downstream time plus upstream time. That is, what is downstream time from this equation? Downstream time is equal to downstream distance by downstream speed plus upstream distance by upstream speed. What is downstream distance? 36 km. 36 by ds plus what is upstream distance? 24 by upstream speed. Total time is 6 hours. So let this be equation 1. Now come to the next set of data. From that you can write 6.5 hours. Total time is equal to, here upstream speed is 36 km. Downstream speed is 24 km. So this is equation number 2. Fine. Equation number 2. So solve this equation 1 and equation 2. Find the values of downstream speed and upstream speed. So how will you find out the values? Say, from equation 1 and 2, 6 by ds, 4 by us is equal to 1. 4 by ds, 6 by us, 24, 36, 13 by 2. So this is equation number 1. Equation number 2, 6.5 is written as 13 by 2. Now add 1 and 2. That is, you have to solve these two equations. In our previous module, we have seen how to solve equations. That is 1 plus 2. What is 1 plus 2? 1 plus 2 is nothing but 60 by ds, 60 by us is equal to 13 by 2 plus 6. That is 60, 1 by ds, 1 by us is equal to 25 by 2. That is 120. 120, 1 by ds plus 1 by us is equal to 25 by 120. That is 5 5s are 5 2s are 10, 24. So 1 by ds plus 1 by us is equal to 5 by, this is equation number 3. Now subtract 1 and 2. If you subtract 1 and 2, you will get 12 by ds plus minus 12 by us is equal to 6 minus 13 by 2. That is 12 1 by ds minus 1 by us is equal to minus 1 by 2. Minus 1 by 24. So 1 by ds minus 1 by us is equal to minus 1 by 24. This is equation number 4. Now add 3 and 4. If you add 3 and 4, you will get the value of ds. That is 2 by ds is equal to 6. Therefore, downstream speed is equal to 12 km per hour. What is the upstream speed then? If ds is equal to 12, what will be the upstream speed? Just have it as 1 by 12, and when it comes to here it will be 3 by 24, it will be 8 km per hour. So you have found, solving the equation 1 and 2 by all this method, you will get the downstream speed as 12 km per hour, upstream speed as 8 km per hour. What you are asked to find? Find the velocity of the current, that is rate of the stream. What is the rate of the stream? Formula: rate of stream is equal to half into downstream speed minus upstream speed kilometer per hour. That is half into downstream speed is 12, upstream speed is 8, that is 2 km per hour. So the velocity of the current is 2 km per hour. So this problem may tend to be a bit lengthier or complex, but it is not so. I have written each and every step to make you understand how to derive at the answers, how to use the formulas, how to get to the end of the result. But when you do it for a competitive examination, you need to just understand the concept, formulate the equations and solve it by shortcut methods. By even observing, you can find what is the value of ds and us, and by mentally, and these you need not write so many steps to find the velocity of the current. Once you know what is ds, what is us, just minus 12 minus 8 is 4, half of 4 is 2, so the rate of the stream must be 2 km per hour. The entire process you should be completed within 60 seconds or so. So detailed practice using proper steps will enable you to complete your problem in the shortest possible way.